Hello everybody, I am Anasuya. I am going to talk about smoothing wind power variability in deeply decarbonized grids. I am from Indian Institute of Science, Divecha Center for Climate Change. I will mainly talk about this with respect to Indian grids. First, let us discuss about India and decarbonization. In India, still coal is the main source of electricity. And we know that coal-fired electricity plants are the major contributor of greenhouse gases. To achieve decarbonization in India, we need to have decarbonization of electricity sector first. Accordingly, in Paris COP21, India has set an ambitious target to achieve 40% of cumulative electric power capacity from non-fossil fuel sources by 2030. As a step towards this, India's renewable energy targets for 2022 are 100 gigawatt of solar capacity and 60 gigawatt of wind capacity. This will increase the renewable share in Indian grid by very high percentage. Now, variability management in a renewable rich grid is very crucial to maintain grid stability and provide reliable electricity supply to its citizens. Now, the variabilities introduced by renewables in the grid can be of different types. The first one is the routine variabilities that happens very frequently. The second one is a low probability, high impact events. So they occur not very often, very seldom, but they have very high impact. So let us target the first one first. So smoothing of wind generation is one of the technique which is used to manage these routine variabilities. Now, how do you achieve smoothing? So, smoothing is achieved by aggregating wind generations from individual wind plants. Now, how much smoothing you get by integrating whichever wind plants? That depends on the correlation between the individual wind speed that is seen by these individual plants. With the decreasing correlation between the wind speed, the achieved smoothing increases. Now, whenever we talk about smoothing, we kind of think of geographical smoothing. What is geographical smoothing? Geographical smoothing is a kind of smoothing that can be achieved by integrating wind power plants which are geographically far apart. And why this is achieved? Because wind speed correlation between any location pairs decays exponentially with distance for certain regions like US, UK and all. However, here we introduce another concept which is called diurnal smoothing. Now what is this diurnal smoothing? So there are certain areas like India which have wind speed pattern in such a way that there is a diurnal cycle in it. The amplitude is also very high for certain locations, the diurnal cycle amplitudes, and the phase angles. That means the time when the wind maxima occurs is also different for different regions. So if we have individual wind plants in these sort of locations, like strategically we put wind plants in such way, then there's a possibility of achieving smoothing which depends on this time of wind maxima, or you can see the phase angle of the diurnal cycles. So we define that as diurnal smoothing. In the next slide, we are going to look at one example or illustration which will make it very evident. So here is the example that I was talking about. So if you look at the left side plot, it's a map of coastline of India, And then the red dots signify 4 weather monitoring stations. In the right hand side, you can see the average monsoon time diurnal cycle of wind speed. And if you follow the pattern, there are 4 curves and they all reach maxima at different point of times. So this means that diurnal phase angles are quite different for all these 4 locations. So this is just for an example and we can use this for diurnal smoothing. We'll go ahead and see what this implies in a very generic scale. So here I talk about the data and the methodology which is being used for the analysis. The input data for the analysis is ERA5 at 100 meter above ground level wind speed magnitude, and it is used for monsoon in one case and the entire year for the other case. So why 100 meter above ground? Because this is the hub height of wind turbines, general hub height. So the analysis is divided in 2 parts. The first part talks about the regular variabilities, while the second part talks about the extreme cases. So the first part we have concentrated on the monsoon months, which is like June, July, August and September, JJAS. Why this? Because this is a time when wind generation is high in India. So here what we have done is we have chosen 3000 random location pairs and calculated the wind speed correlations between these pairs and tried to explain them with the help of the separation distance between them and the difference in time of wind maxima between these pairs. This is the first part. For the second part, we have used a stochastic weather generator called IMAGE. Why this? Because we don't have that long historical data to have an idea about these extreme events. Here we could simulate 1000 years of data and we could look at the extremes very closely. So we analyze whether we have wind droughts all over India together or different areas face wind droughts or no generation days with respect to wind at different point of time. So here we present you the first part of the analysis and the result which we got. So to start with the smoothing and the separation distance. So what is the impact of separation distance on smoothing, or we can say the correlation coefficients between individual pair of locations. So if you remember, we had 3000 location pairs all over India and we calculated the hourly wind speed correlation between all these location pairs for 2014 monsoon season. And this is plotted in y-axis, while in x-axis we have different distance speeds. So which increases, like the first one is 0 to 300, the second one is 300 to 600 and like that. We see a decreasing pattern with increasing distance. However, each bin, this green blocks, these are actually box plots. So the middle line shows you the median, 50th percentile. The bottom one shows you the 25th percentile and the top one 75th percentile. But there is a spread, there is a distribution, there is a large distribution for each bin. So now we try to find out what this distribution depends on or why we get this distribution. We find that for each bin, this variation, this U-shaped curve depends on the local wind maxima or the difference in local wind maxima. So the timings, if they are more different, like they have a difference of 12 hours, then you get points like this. And then when they are not that, you get points like this. So this brings us to the next part of our analysis. So this is the result from the next part of analysis. As we can see, this talks about low probability extreme events. So what are these two plots about? The left side plot shows whenever you have a wind drought in Rajasthan, which is signified by this red color, you still continue to have these blue patches in South India, which means that you continue to have wind speed still in South India. And this is vice versa, because in the other plot, the right side plot, when you had the wind drought, which is signified by this red color in South India, you continue to have wind speed in Rajasthan. So this means that all over India you don't have wind drought at the same point of time. So interconnecting areas might help you, like interconnecting the grids of these areas might help you to avoid regional grid level wind droughts. Now, if we consider two locations, one in the southern India and the other one is the northern India, and check whether we can achieve the regular smoothing by them, we see yes, that's possible. And coming to the extreme events, we saw just now that yes, it is actually possible to avoid those wind droughts. So that means we should balance the wind plans strategically between these two locations. This is one of the case studies. We can find different places, I'm sure. But there are certain prerequisites which depends on policies. The first one, why would a person put wind plants in such location which gives you smoothing? While they actually don't get, the wind generators don't get benefited by putting wind plants where you get smoothing. The benefit is for the utilities or the grid operators. So we must have certain policy intervention. The other one is, what about the grid connection? Are these places well connected or not? If they are not, then what intervention from policy perspective we need? These are the two open questions with respect to policy. Here we discuss the first policy intervention, which is respect to incentivizing the wind generators to put in plant in strategically way so that we achieve smoothing as well as wind generation. So from the revenue perspective of these wind generators, still smoothing has no values. So we have to look at it how they can be incentivized when they put a wind plant in such a way that you have a benefit of smoothing also. Coming to the second policy intervention, there is a need for policy to assess strengthening of grid across India. So as you can see in this right side plot, there are 5 regions with respect to grid in India, and all of them are not connected that strongly with each other. So earlier, pre-renewable era, during that time the coal was concentrated towards the eastern side, and that's why the western region, northern and southern region had connections with eastern region. However, now we have renewables coming up in northern, western and southern region. So we need to modify the existing connections and we should have new inter-regional grid connections. This requires a lot of money as well as time. So this is a high time that we come up with certain policy intervention to assist in doing this. What alternative do you have other than this grid interconnection? You can have really large storage. However, that also is very cost intensive. But there is another point with which I would like to conclude. So this wind power variability is available in different scales, like different time scales. So to manage them, we not only need one solution, but we need a portfolio of solutions. So that include, one of them is this transmission lines, interconnection. The second one is storage. We also need demand side management. So actually we need a policy to assist in having this different type of solutions for this problem. Here are a few references. We would like to thank National Institute of Wind Energy, NIWE, and for funding, we would like to thank Government of India, Ministry of Earth Sciences. Thank you. Please feel free to contact me in the given email address.